Today we will have second session for of the day 6 of this online FDP program. Now, without late, I request Bammidi Roop Sandeep Garu, Assistant Professor, Mechanical Engineering Department, to give brief introduction about Saravana Kumar Perumal, followed by his session. Over to you, Roop Sandeep, sir. Thank you.
Yeah. Uh, Good afternoon, one and all. Myself, Roop Sandeep. I am the Assistant Professor from Department of Mechanical Engineering, Aditya Institute of Technology and Management, TKL-MECH. It is really our privilege to introduce Sri Saravana Kumar Perumal, a distinguished expert in manufacturing engineering, artificial intelligence, and machining technologies. He holds a Master of Engineering from the Anna University, a gold medalist, and a bachelor's in mechanical engineering from Institute of Road and Transport Technology. With over 14 years of Dassault systems, he specializes in machining simulations, computational geometry, and robotics. Currently, he pursuing an executive PG program in artificial intelligence and machine learning at IIIT Bangalore. He brings cutting-edge expertise to the field. We are honored to have him as our resource person today. And now I request Sri Saravana Kumar Garu to take over the session. And it is very happy to have you such an inspired personality in the diversified areas in the engineering and sciences. Uh, Thank you, sir. And I request Sri Saravana Kumar Garu to take over the session.
Thank you, sir. Thank you, Sri, and thank you one and all. And so this is Saravana here. Am I audible?
Yes, sir. You are audible.
Yes, sir.
Okay. So today I'm going to present role of AI and ML in digital manufacturing. So I divided into two parts the entire session. One is basically I'm from mechanical background, and I studied computational geometry during my initial career of my work, and then I moved to robotics, and then I worked on shipbuilding, and now I'm working on machining simulation. And so I have plenty amount of domain expertise in especially robotics and manufacturing. And so now currently we were working on few of the technologies which are emerging, and it is very exciting. So we will slowly I'll just give you the foundation of all this work, and then I'll dwell into the applications of this technologies. So generally, we most of you already know that. So AI is a very long journey. It started around 1950s, and the journey, and slowly we are from AI to machine learning, and then from machine learning to move on to deep learning, and deep learning to generative AI, and we are moving on to now towards artificial general intelligence and artificial super intelligence. So AI is a broad sense in that you can automate many things. So ML, again, it is a programmable intelligence, and DL is specific set of machine learning, which is applying neural networks to learn certain things. And Gen AI, again, on top of the very narrow area of deep learning, which is specifically focusing on transformer architecture and derived technologies. So it is going every day. New models are coming up, and new technologies are overwhelming in the market, and it is proven to be a outstanding performance in many areas like engineering and reasoning and general intelligence and whatnot. So you have many broad spectrum of applications today, and it's penetrating into almost all areas of applications like in engineering and banking and image generation and entertainment and gaming. So it is continuously evolving and exploding. So we'll slowly Okay, so I generally put this slide to understand better what is a computer will do and what human is, and what better can understand from what is easy in the point of human beings and what is easy point of computer calculations. Like, see, left side, I kept a Ketia surface, let's say third order, fourth order spline surface, where if ask anyone, a human being, to compute each and every point on the surface, maybe taking a lot of time, right? So you have to compute that each and every point, and you have to evaluate, and it will laborious work. So far we have been using the computers to do repeated calculations. More of is very very tedious for any human being. The other way around, the right hand side, I have kept on picture. If you ask any human, you just tell me what is it, at least they'll immediately tell us, okay, it's a picture of a tiger. Okay, so then what is it actually? In some more guide, they can interpret as, okay, it's a Siberian tiger. One more classification. Okay, so but if you give the same picture to the computer, it is not that 100% may not be possible earlier. So that is what we are trying to achieve now. What are the easy for very human beings, which can be easily taught to the computer, like decision making, or okay, just human intelligence about so identifying a picture or whatever the conversation, whatever. So that is what that. So we have been so far. We are very good at repeated calculations. Now the shift is towards human intelligence, like which are very easy for a human. So we are trying to adopt the same in the computer. Okay, so that's a broad sense of what's happening today in the area of AI. So I am from computational background, so I express my own feelings in the terms of geometry and topology. Okay, so generally the what we are doing so far is the deterministic algorithm for any of the model what we do in CAD/CAM area. So let's say we have one-dimensional line, and then we move on to two-dimensional curve, and then we move on to three-dimensional surface. Yeah, it's a dimensional based, like we have one-dimensional lines, and then two-dimensional planar curves, and then we go to the three-dimensional curve. So here also we do certain kind of approximations when you have something kind of if you have let us say if you have many points on the line, so you want to draw a curve on the line, we do deterministic, the OLS method, or some kind of a method which we approximate that polygons and then find the intersection of all the points on the curve. Finally, we derive that approximate a curve which is passing all through the points. So similar things which we are going to explore in a different way, in a different sense, when you have a more dimensions in a if you have a more dimensional space. So you can imagine one-dimensional in your mind, like that line, it's a straight line, so one-dimensional again. Two-dimensional x, y, and then x, y, z, three-dimensional, beyond which you can't easily imagine. But the idea here is the same concept what we are using is two-dimensional and three-dimensional can be extended to n-dimensional as well. I mean, the algorithm which we are using inside the artificial intelligence is dimensionally independent. What I mean to say is, suppose we are having a n-dimensional problem, it cannot easily visualize, but you can apply the similar logic what we are applying for the three-dimensional space to the n-dimensional problem. So I just move on to basic calculus rules like constant rule, power rule, sum rule, and product rule, and chain rule. So these are the rules actually governing that most of the AI algorithms. So especially the chain rule, which is used for back propagation and neural network error back propagation algorithms. So yeah, these are the basic rules which we know. already for any of our calculus topic, right? So we just move on to another a small intuition behind what is a parameter, in the sense we used to call in artificial intelligence and machine learning technologies, we used to call parameters. To idea of what is a parameter, I will just give you some kind of intuition here. So we have many cloud of points, I mean 2D space, and we have so if you ask you to fit a line passing through all points, obviously impossible. So I request you to put fit a line which is approximate, it is which with a minimum error, right? So that is any way you can put it. But the problem here is if it goes beyond, let's say here only 2 features we have taken, and let's say we have y equal to mx plus c, and we find m and c, and we just fit a line which is approximate to all the points. But in real-time scenario, we have n number of features, I mean independent variables inside the system that we cannot easily interpret, and then there is a computation complexity in that to identify the parameters for that particular n-dimensional space. For that, what we are using is that a gradient descent algorithm, where here there are 2 parameters. We have two independent variable which will create parameters, 2 parameters like like the shape in a 3-dimensional space. So all that we just give a model, we find the errors, we project those errors in the 3-dimensional space like this kind of a structure, and or in the more or less the error function which we are going to minimize, which have the shape of this kind of for the 2 parameters. So we use that gradient descent algorithm to by iteration to reach the minimum error of this entire function, so that we can best fit the line. The same logic is applied for all the neural networks using the back propagation algorithms. So okay, so just having said that, so just have you just experience that. So here it's a tangent which we are drawing in this line, where we have here is the minimum for the y equal to x square, and it's a positive slope is high towards the right hand side, and minimum at 0 in the middle, and then left the negative slope. So if we have any error function and second quadratic error function, or if you plot that function in that graph, if you allow that the parameter which to minimize that, so if we have identify mechanism to reach the minima of this curve, then we will have a better approximation on the model. So similar thing is employed in the gradient descent algo, where the parameter is allowed to flow in the I mean the descent towards the minima, so that we will get a best approximate function of the given points. So next we'll dwell into neural networks. The same here, the inputs are we have input layer, hidden layer, and output layer in any typical neural network. So input layer is always 1, but whereas hidden layers we have one or more hidden layers, and the output layers only 1. So here what we are going to do is like initially we have discussed only 2 parameters in the problem in the previous data set, but here the parameters are more, because each line here arrow indicates a parameter, and also weights bias. We used to call weights in neural network terminology, and outputs again. And so this model actually, see, previously the used model is actually approximating only one linear function. But this model, where in which this neural network can approximate any kind of mathematical function. So if any of the function, if you have a very complex in nature, which we are unable to easily mathematically express, we can approximate using the neural network. That's all the neural networks behavior. So yeah, so we'll move on to next type of neural network. Here is the other the next version of neural network is a recurrent neural networks. This model proposed for the time series data, wherein which if you are previous state of previous state of a model has to be fed into next state, like a prediction next word, or predicting the next next sentence, some kind of a work. This recurrent neural networks are expressed. So and another type of neural networks are convolutional neural networks, and this neural networks mainly works on images. See, if you have an yeah, hello. Okay, so so this convolutional neural network better works on the images, where in which the image on the each image there is an operation called convolutions and max pooling, and sequentially we do that. We extract the features and then fit into the neural network, and then we find out what is the classes within an image or some kind of work. The next addition to the deep neural networks is generative AI, where in which we have a mechanism called attention, where in which we have many kind of many kind of so this difference between this also addresses the sequential problem, but in different way, where in which recurrent neural networks works on text data, wherein which Gen AI also works on text data, but the operations on the Gen AI can be massively parallelized. That is the only difference between the and also it had a attention mechanism, and there is a attention mechanism and then feed forward neural network, and then the combination it produces a lot of newer technologies and then applications nowadays, and then DeepSeek and Gemini and all the LLMs are based on this Gen AI model. So we have been discussing the few of the technologies which are available in our market, and we'll slowly dwell into applications of these technologies. So we move on to a resource program and AI search. So I'll just brief you a paper. So this neural network can also learn a program. I mean, the sense if you see that neural network model, initially this code2vec proposed with Python and Python and TensorFlow and Keras. I hope a few of you already familiar with the neural network and also the frameworks which provides you for deep learning network in Python. So here they have already demonstrated a Java or C# program to predict the properties of the program. Let's say we have a Java program. We want to understand what that Java program does. Similarly, we have a C# program. We can understand. We want to understand what a C# program does. Similarly, we can understand that the robot program and machine program and so on in our manufacturing sector. So I just it's an open paper where I just show you how this are implemented. So I just I'm showing that. So this each and every program is converted into a abstract syntax tree, I mean AST, where in which the flow of each statement, like if condition, all that will be created like a tree structure. So this tree structure would be fed into a neural network, and we assign that uh, based on the output. We assign that, predict that what kind of a program it is for the during training time. And for the new programs, if we feed again, which is the not tagged, we mean that program we don't know what it does. Then if we feed to the neural network, and it predicts what kind of program it is. So the same technology can be applied to the robot programs, machine programs in machining applications. So this abstract syntax tree is the one which we are going to feed into that neural network, and then the neural network predicts that what kind of a program it is, and then we classify them. And for the during training phase, during the inference stage, we get a new program and give it to the network, and then it identifies what kind of a program it is. This is applicable in most of the coding assistant nowadays. So even if you have in a development environment, nowadays the people are coming up with the AI assistant for a coding. Let's say if you give some kind of a area in which you want to do a coding, and it will pre-trained on your code database, and it will give you what is existing method of how this program can be written, or similar programs. It will, or duplicate code in your entire framework. All that you can just find out based of this technology. So here we have just demonstrated something which is original manufacturing cell, which we have it's like a robot or machine, whatever the resource. We identify those programs, and then we can convert that into an abstract syntax tree, and then feed into a neural network and predict that what kind of a program, so that we can classify what are the programs in our entire database, and find a new part it comes, and we can find out what is the closest matching programs among that available in a database. So this kind of this kind of a work can be extended to apply to any of the manufacturing applications, like any program related task in a large scale environment. So we'll move on to other technologies using point cloud data. So this is actually used for resource reduction in a large environment, like entire factory. You can want to resource allocate, and then you can move on, and you have to use this free space, all that. You can use this technology to identify that what are the resources, identify them, and then you can reuse them, and then you can plan the layout better way. So here the lidar, I mean, like sonar and radar is a lidar is something like a light detection and ranging. So usually lidar produces enormous amount of point cloud data. I mean, the sense of what is the point cloud data? It's nothing but points on various objects. Lidar works, it's like you just send a light signal, and it again bounce back from the object and gives you the distance of the object. So if you scan that lidar and the entire manufacturing work cell, or it may be the entire city and whatever, so you will ended up in getting enormous point cloud data. So those point cloud data can be tagged or pre-trained to utilize that what are the objects which are available in a factory and what and so on. So I'll give you brief idea of different ample amount of work is done on this area. One is Voxnet. So Voxnet is it's voxel actually. See, it is something like it's each and every cell is something like a block like this one. Okay, so like whether that point is inside the object or outside the object. By the way, we can build a voxel of the object. So other pioneering work is done on the similar identifying a 3D model from the point cloud data is a point net. The other exciting paper you can just go through. Here you can see that there are a lot of points from the model from the lidar. So those points are again fed into the network, and then it is identifying that what kind of object it is. So what is the difference between that that paper and this one is directly it works our point cloud data. You need not to do any other additional task. You can use directly this network to segment that point cloud data and identify the objects inside the point cloud data. So other interesting paper is the point CNN, point-based regional convolutional neural network. This also does that similar kind of thing, which we can identify the objects from the point cloud data, where you can use that same for driverless vehicle and so on. So it identifies the bounding box of the given point cloud and then identify and categorize it based on neural network and then identify the what kind of object it is. So similar kind of technological foundation can leverage our manufacturing cell, wherein which there are humpty number of different machines and then robots are working together, and then we can modeling entire virtual factory may be very time consuming and it will be taking a lot of effort, wherein which you scan that entire factory using lidar and then give the point cloud data and identify the resources and tag them and then plan your better factory. So the other applications on the similar A&ML technology for identifying resources in a work cell or at a factory environment. The third application which I am going to show is that additive manufacturing. I hope you have learned yesterday additive manufacturing a lot. That continuation of that. So I have another paper which I have giving you that to rough idea of what the technology behind that kind of work. This is another neural network called UNET, convolutional neural network. It is fantastically working on image segmentation, and initially it is proposed on a medical imaging and then to identify the boundaries of medical X-rays or MRI images, all that. It's a cool technology where you have an input image and then there is a left side is a encoder and then right side is a decoder, where in which image input and then we just pass that this is called a skip connection to the input to the output. So it we give that entire image and you segment it and then you learn the features inside the image. So that is about UNET, convolutional neural network, where it's primarily used for image segmentation. So this would help us to address many of the industrial use cases where you have a picture image of your part or whatever it's having a defect, to identify the defects, or if you manufacturing parts, if you have a defect or not, all that kind of applied on top of this model. So one use case I'll just to show you that powder bed fusion, where you have already, I hope yesterday those who attended the additive manufacturing have a right rough idea of what is powder bed fusion. So it for those who are not part of that, I just laser heat source is applied on layer by layer on the powder, and then we selectively melt it and then create a additive manufactured product. So here, for rough idea of what is happening in that laser melting, you can see that so the specific area of whatever you want to melt, and then it selectively melt on the part, and then again powder is poured again and again it melt. So that's all about powder bed fusion. But see, sorry. Yeah, okay. So first, so give a rough idea about this. Different builds are, we used to call it as a build, and then there is a layers. So hundreds and hundreds of layers will be there to manufacture a product, and each layer it will be having a scan of just pouring a powder on the each build, and then again melting it, and it is a highly time-consuming and manufacturing, a very complicated, and also it's very expensive process. So we those each and every image on each and every pass, we can take those images, as I already explained you, that unit or kind of a segmentation CNL neural network, and we analyze the properties of each pass, and then also if we can train the models for the what the right one, and then what is it defective one, all that, and then we can reuse that to identify or predict a model is going to be correctly going on in the machining process, or if it is going in the wrong, and intermittently we can stop and we can restart the process. So to identify that, we can use that convolutional neural network. So these are all the applications, but not only here, there are many other places, defects on the part and defects on the any image-based machine system can be utilized to take the images and then process using the neural network, and then segment it them, and then find out is there any defects or identified. You can just identify those, and then we can just pass on them, and then we can just segregate what is it, what we can check on the quality of the product. So another application which I'm going to explain you on the subtractive manufacturing, which we have released a machining AI assistant this year, wherein which it will suggest automatically a machining parameter, and also it will generate generate manufacturing operations for given given a part automatically using a assistant. So to just to show you more about subtractive manufacturing, as a like a milling and a lathe or 5-axis machining, all are we used to call a subtractive manufacturing domain. So typically inside it will have a tool path, and as well as tool, and as well as production part, and as well as the stock. So here left side is the tool path and the tool, and right side we have a stock, and a tool is removing the material for the on the stock. So this each and every part, manufactured part, will have hundreds and thousands of operations on them. So to select that each and every feature and then program it may be very tedious task for the engineer to do the task. So what we have proposing is that one model which will automatically learn that each and every feature, and then it will identify and it will propose you the parameters for the particular operation. So for example, we are taking a pocketing operation, and then we are trying to do some strategy on which we are going to machine that entire pocketing operation. An AI assistant which are already trained with the known how data, with which will propose the alternate strategy for a particular manufacturing operation with the better results. So let us say if you have hundreds of parameters for a particular manufacturing operation, and then we want to simulate that particular operation in our tool in Delmia machining application, and then we want to automate and okay, we want to have a better parameters for the particular machining operation. We propose based on the previous trained AI model. It will suggest you the better parameters for the given operation, and then user can integrate that which will propose you many solutions what it already based on the time, all other many other factors, and then user can adopt any of the proposed operation, and yeah, to speed up the process. So other which we have released recently, that a complete AI capability in Delmia machining applications, wherein which we given a part, and then we'll end to end we program that entire part. Earlier it used to take hours and hours of human effort to program that part. Now with the AI, help of AI, you can directly model it within a few minutes. So I'm just playing a video, and I hope you'll enjoy this video. Yeah, 1 second. Yeah, this is a complete solution of our AI framework, wherein which we get that features based on feature recognition, and then we use AI tools to and based on know-how earlier, we program that entire operations on the based on the features which automatically detect the features on the machine application. So this is one among that work which we have done so far. And yeah, so this is all about I'm going to present. I have planned to present today, and open for the questions. The session is, yeah. Thank you all. Yeah.
Sir, sir, am I audible, sir?
Yes,
Yeah,
Hello.
yeah. You are audible very much. Yes, you are
Myself,
very much
Dr.
audible.
D.S. Naidu,
Yeah.
mechanical department. Sir,
Yes.
for this AI and artificial intelligence and a mechanical engineer, how can able to learn, sir? At what extent we can able to learn, sir? Actually, the software engineers, what way they will do and what extent we can learn. Actually, this is the new
Okay.
area, na? Everybody using
Yes.
this buzzword.
Yes.
And
Yes. Yes. So that's a very good, fantastic question. So take about me. I am a B mechanical engineer and then ME manufacturing, and then joined in CAD CAM, and then now working on AI technologies, and then learned computer algorithm, program, everything. So today it's always engineering is a cross disciplined cross domain discipline. So where in which you have to work on various new technologies, and then we have to produce the outcomes from the various new technologies which are already coming up. So one good thing about that, other than like, yeah. So one difference which I could suggest you is that one thing is that, see, if you want to compile a C program, you need a C compiler, and it is a lot of other large stuff you need. It is in the background. Like, say, if you want to compile certain libraries, it is all expensive and it's very difficult to get all that. But for the AI, most of the things are in open source. Like if you like deep learning frameworks like TensorFlow, Keras, all that are open source. And also it is very less programming is required on the AI side. It is only an empirical empirical work. I mean, the sense what I would like to say is that the long long prolonged work is not required to jump into AI. I mean, the sense, if you want to, let's say, if you want to learn, I'm showing, I have shown few of the CNN topics, right? So need not to rebuild the entire CNN model. You can just reuse the existing model, and then you can just train on your data, and then you can come up with a quick solution. I mean, you can reuse the pre-trained model. Likewise, the transformers, what we are art of technology today, is a reusable model, which means you can import the weights of large language models or LLMs, and you can reuse those weights, and you can build your own inference based on the weights. There are many open source models are available. You can download those weights and then inference. So by looking at outside, it will be very, very difficult. But I would say it is not. See, let us say if you want to compute a spline surface, or it is mathematics begins on the blend surface, or the extensively complex in terms of mathematics, and also you need a lot of skills. But to understand neural networks, all that, you have not that kind of I would say not that kind of a deep in mathematics, but it's more or empirical, and then it is something like you can experimental, you can add it on top of your existing knowledge which you have on your career. But this is more of the data. I mean, in the sense, the large in the aspect of data manipulation, data fetching, and then tuning, all that is the very complicated stuff, rather than that the underlying the maths behind that. I would say you can easily feel that what is an LLM on your laptop as it is. Like, you can download a transformer model, you can train, and it is all that you can do on the free of cost. That's one advantage on AI right now.
okay, thank you, sir. We understand your section very well. Enjoyed, because
Yes.
it is little understandable for us. It's new in that area.
Yeah, I understand. So yeah, now yeah, AI is just going inside almost all the departments like manufacturing and banking, finance, and general intelligence and general inference, and then image generation. There are variety of tasks you can automate using AI and LLMs. And of course, that CNN is having a very fantastic output on the images and captured images, motion, and then analyzing a video, captioning a video. There are n number of applications you can implement on the manufacturing side. But only thing is we have to take our efforts to identify the use cases, come up with the solution, and then we have to productize. Now, the past few years, this has been picked up in our huge momentum in our side. So people are coming up with the new ideas, new product. Then yet to all that, yet to reach the market. So it's just revolutionizing almost all the CAD CAM industry, and new products are coming up. Like automatically given a part. There are many products available. A few products available on the market. Like just to give a part, automatically generate an NC program. That's fantastic, right?
Sir, this AI manufacturing, that Dassault system is given any software, sir, for training? This what you have shown, right?
See, we have you can talk with Sri. You can talk with Ravikiran. It's I think few days before he had presented. So we have industry and academia partnership. I think we are running a academia program where you can get academic licenses for your work.
Okay, sir.
And you can have a tie-up with your college, and then you can tie up with we have a program for entire India. We most of the licenses will be given at free of cost for the students. So you can interact with our 3D experience platform using academia licenses. But I can give you to whom to contact industry academic partnership program for us to engage with our tools.
Okay, sir. Okay, thank you, sir. Thank you very much.
Yeah, welcome. Yeah, of course, it is a pretty new area. So I kept this very simple, and everyone can understand the entire content of my presentation. And I hope you all enjoyed it. And if you have any further questions, and we can discuss.
Sir, from my side, a small question. That is
Yes.
there any tool to generate the assets? Any if you consider any material fabrication or material compositions, if you want to work on that area, if I want to implement the machine learning or the artificial intelligence, any section of that, is there any tool to implement or to generate the data sets for further generating the different type of apps?
Yeah,
In between
exactly.
the
So that's
material
a fantastic
fabrication.
question. Yeah. I understand your Rufus and Deep. Okay. Yeah. So I understand the biggest problem in AI technology is the data generation, as you said. So data generation, data augmentation, there are n number of difficulties during. See, many AI models failed only due to lack of data. They have a fantastic idea in the market. You can achieve anything. Like there are many very good ideas are coming up, but only this not because of we don't have AI algorithms, or not because of we don't have a technology, but only because of the data unavailability, and we would not able to successfully productize that AI technologies, and especially tagged data, for example, and like X-rays, right? So you have an X-ray, and if you want to identify any bone defect on the X-ray, of course, a nice model idea, but only lack of tagged data we used to call, right? So if you say for A works it like that, first you want to identify the exact data matching which your problem. Okay, so which had a pre-trained, which should be trained on the model. Like like if you have, let's say, if you want to, in that case, what we are going to identify the defects, which means that you need a without defect and with the defect images to identify exactly to what defect on the part can come. So that is the difficult in the data part of the AI models. So to train a model, you need a extensive amount of data for the particular, which is marked as a features of that particular data. Let's say if you want to identify a cat, given hundreds of thousands of images, you need the cat images for hundreds and thousands of cat images, various postures, how it has to look, all that has to be fed into the neural network, so that the weights of the neural networks will be updated based on the pre-trained model. Then in which you can give the new image and it will identify and it will caption as a cat. Otherwise, it will not. So that is what. So even LLMs or something like it. See, this CNNs are working on images, and then generative AI and RNNs are works on the text data. So you need to train the model, and it's like if you say LLMs, if you have billions and billions of parameters, and then you have to train this model, you need a lot of data. Otherwise, the model will go underfit, or so it will not perform at all. So that's a problem in AI. So
Yes,
you
thank
need
you,
a
sir.
data. Yeah. So data is the crucial thing which you want to build any AI applications. Not because of the ample amount of algorithms. It's not because of that ample amount of ways in which you can build the system. The only crucial part is that getting the data.
Yeah, thank you, sir.
Yeah. Welcome.
So I request the participants, anyone can ask the questions.
Yes.
Any participant? Yeah, I hope there is no question further. Thank you, sir. Thank you so much for your valuable session and the inspiring session for the researchers, basically, who is focusing their research in artificial intelligence and machine learning. And you have covered the best topics like computational techniques, conventional operations, and neural networks, which generally enhances the efficiency and precision. And also, these three technologies are driving smarter, faster, and more precise manufacturing, especially in the manufacturing sector. And really, we are very happy to have you in this session, sir. And your lecture is one of the inspiring for the each and every one who is working the academia industrial sectors for their out focusing multidisciplinary activities in the research sector. So thank you, sir. And from now, I'm handovering the session to Dr. D. Santosh Kumar.
Thank you, Sri Roop Sandeep Garu. And thank you, sir, Saravana Kumar, sir, for your wonderful presentation. Yeah, all the participants, stay tuned. So we will be having next session, which is going to commence from 5 o'clock, 5 p.m. Sir, you may leave, sir.
Yeah. Thank you, everyone, and have a nice evening and enjoy your rest of the sessions. Have a nice day. Bye bye. Signing
Yeah.
off.
Thank you, sir.
This